Determining functions. Determine whether the relation is a function. Give the domain and range of the relation. First, we're going to identify the domain of the relation. The domain is the set of all the x values, or the first components, and we don't need to list duplicate numbers more than once. So, to list the domain, we'll just write the set of all unique x values. And we have a 1 and a 2. So our domain is 1 and 2. Next, we can list the range. And the range is the set of all unique second components, or y values. And again, we don't need to list any duplicate values. So we have a 3 for the y, a 4, and then we have a 3 and 4 again. So our range is just 3, 4. Now we want to determine if this relation is a function. Now the definition of a function says that each member of the domain corresponds to exactly one member of the range. That means that no two ordered pairs of a function can have the same first component with different second components. So if we look at the first two ordered pairs, we have a 1, 3 and a 1, 4. Now you'll notice that the first components are the same, they're 1, but the second components are different. There's a 3 and a 4. So since the same first component has different y components or different second components, that means that this is not a function. Now similarly, we could have looked at the last two ordered pairs, and the 2 and 3 and the 2 and 4 also tells us that this is not a function because we have the same x values, but they're going to two different y values. So that means that this relation is not a function. Determine whether the following equation defines y as a value of x. To do this, we're going to solve the equation for y. So I'll move over an x squared on both sides, and we have y equals 64 minus x squared. Now, we can say that y is a function of x if for each value of x there is only one value for y. So if we plugged in any number for x, it doesn't matter, we would only get one value out for y. So that means that the equation defines y as a function of x. So yes, x squared plus y equals 64 defines y as a function of x. Determine whether the following equation defines y as a function of x. Here we're going to do the same thing. We'll write the equation and solve for y. In order to isolate the y, I need to take the square root of both sides. Remember, when taking the square root, we need to put a plus minus sign next to the radical. So our equation is y equals plus or minus the square root of x plus 3. Now, the equation defines y as a function of x if for a value of x we only get one value for y. But this plus minus sign means that we could potentially have two values for y when we plug in a number for x. For instance, if we let x equal 6 and solved for y, we would get y equals plus or minus the square root of 6 plus 3, which equals plus or minus the square root of 9, which equals a positive 3 or a negative 3. So as you can see, I only plugged in one value for x, but I got two values for y. So that means that no, the equation does not define y as a function of x.